Let us discuss about uniaxial stress on oblique plane. See, this is our oblique plane. This plane is represented like YY and it is having an angle of theta with our perpendicular plane XX. See, this section where tension force P is acting perpendicular to it, that section is our XX, and we are cutting an oblique plane like this YY. So that this is our oblique plane YY. So on that we have stresses sigma n and tau acting. This is our normal stress sigma n and this is our shear stress tau. So we will have this case. Now we will have to resolve forces in such a way that we get the value of sigma n and tau. See, corresponding to sigma n, let us resolve this. Okay, here we have P force acting like this. So P is acting like this angle is theta, so corresponding to sigma n we will have P cos theta, and corresponding to tau, here see the tau, so corresponding to tau we have P sin theta. This is corresponding to tau and this is corresponding to sigma n. Also we have here the cross sectional area at x-axis is A, and at this angle theta we have our YY plane. So YY plane is having area of A by cos theta. So this and this are our important figures. From this we can find out sigma n and tau. So sigma n is equal to we will have, see here P cos theta is acting over an area of A by cos theta. So P cos theta is acting over an area of A by cos theta. So our value of sigma n will be P by A cos square theta, and tau is equal to, see, P sin theta is the value of tau, or the load, the force of causing tau. So P sin theta is acting over an area of A by cos theta. So P sin theta is acting over an area of A by cos theta. So that will give you P by A sin theta cos theta, or P by 2A sin 2 theta. So this is the value of sigma n and tau. Sigma n is equal to P by A cos square theta and tau is equal to P by 2A sin 2 theta. So we will have a theta is equal to, we will have to find now the maximum value of sigma n and tau. See, for what value of theta sigma n will be maximum? At theta is equal to 0. So that is the perpendicular plane xx itself. At that place we will have sigma n maximum. Sigma n is equal to P by A then. And when theta is equal to 90 degree, cos square 90 degree, that will be 0. So we will have sigma n is equal to 0. So that is the case with sigma n. Now when tau is maximum when theta is equal to 45 degree. So when theta is equal to 45 degree, sin 2 theta will become sin 90 degree, that is 1. So we will have a theta is equal to 45 degree, tau is maximum, that maximum value will be P by 2A. So we have got this much. So our derivation is complete. Now we'll do a problem based on this. A metal block of 100 mm square cross sectional area carries axial tensile load of 10 kilonewton. See, this axial load is 10 kilonewton and the cross sectional area here is 100 mm square. For a plane inclined at 30 degree with the direction of applied load. See, the direction of applied load is like this or parallel to this one. Calculate normal stress, shear stress and maximum shear stress. So with the direction of load for a plane inclined at 30 degree with the direction of applied load. So the plane is inclined at an angle of, see, this YY is our plane. So this is inclined at an angle of 30 degree with the load. So this angle here, this angle will be our, what is given. So this is our 30 degree. Understood? Let us read it once more. For a plane inclined at 30 degree with the direction of applied load. This is our direction of applied load, and to that the plane is inclined. This is our cut plane and that oblique plane is inclined to the load at an angle of 30 degree. but the theta in our equation is the angle between two planes, the perpendicular plane, or this one, the x plane is perpendicular like this, perpendicular to the load P. So that plane and the oblique plane, that is our theta. So here from the figure we can understand that this is 90 minus 30 degrees, so that is our 60 degree. Now the problem is fully solved. This is the complication in this question. We have to find out the value of theta. The value given is not theta. The value given in question is the angle between the load and the oblique plane. We have to find out the angle between two planes, not the load and the oblique plane. Okay, so our 60 degrees is our theta. So our full problem is solved. Now we have to find out the normal stress. Normal stress sigma n is equal to P by A cos square theta. We will have P as 10, A as 100 mm square. So let us put this as in which unit I have to represent Newton m per mm square. So this into 10 to the power of 3. Here 100 cos square theta. So cos square 60 degree. So that will become 10 to the power of 100 cos square 60 degree. That value will be 25. 60 is 1 by 2 whole square cos square, so 1 by 2 whole square, so that will be 25. Now this much MPa. Now tau will be P by 2a sin 2 theta. So P is 10 into 10 to the power of 3 by 2 into area 100. Sin 2 theta is sin 120 degree. So solving this, we will have answer as 43.3. This will be the answer. This much MPa. Also we will have to find out the maximum value of tau. That will be P by 2a. So that will be tau is equal to P by 2a. P is given as 10 into 10 to the power of 3 by 2 into 100. That will be 100 divided by 250 MPa. So this is our figure. See, the load P is acting at 10 kilonewton. Here this is our angle of theta. This value 30 degree is given. This value will be 60 degree. At this oblique plane we will have sigma n is equal to 25 and tau as 43.3 MPa. Okay, and at tau is equal to 45, theta is equal to 45 degree, we will have tau maximum as 50 MPa. So the question is solved. Okay.